For 5,000 years, Stonehenge kept its secrets. Kings, monks, antiquarians, and finally scientists with lasers and satellites all took their turn trying to crack it open. And every generation walked away with a slightly different guess. Then, in the space of about 6 years, something unusual happened. Geologists traced one of its stones to a spot 750 kilometers away. Archaeologists ran a scale model through a sound chamber and heard something no one expected. Isotope chemists cracked open cremated bone and found people who were never supposed to be there. And across almost every one of these breakthroughs sits the same quiet detail. The answers came from computers doing what human eyes and hands could never manage on their own, sorting through mountains of geochemical, acoustic, and skeletal data using statistical modeling, and machine-assisted pattern recognition that simply did not exist a generation ago. This is not a story about a single AI switching on and solving Stonehenge overnight. It is something more interesting than that. It is the story of what happens when decades of scattered data collected by hundreds of researchers who never spoke to each other finally get processed together. And what came out the other side is stranger and more human than the monument's reputation as a pile of mysterious rocks ever suggested. Start with the ring of holes that almost nobody outside archaeology has heard of. Just inside Stonehenge's outer bank and ditch sits a circle of 56 pits, spaced with rough evenness around the monument. S-edge. They are called the Aubrey Holes, named for John Aubrey, the 17th century antiquarian who first mapped them and guessed, correctly as it turns out, they were older than the giant stones everyone comes to photograph. For most of the 20th century, the Aubrey Holes were treated as a footnote. Some contained cremated human remains, some were empty. Nobody could say with confidence what they were originally for, and the leading guess was that they once held a ring of timber posts or small stones, later robbed out and repurposed as a burial ground. That changed with a straightforward but powerful piece of arithmetic. 56 is not a random number. The moon does not simply rise and set in the same places every night. Its rising and setting points drift slowly along the horizon over the course of a cycle lasting 18.6 years, a period known as the lunar nodal cycle. Multiply that I3 and you get 55.8, which rounds to 56. Researchers, including archaeoastronomers such as Clive Ruggles at the University of Leicester, have pointed to this near-exact match as one of the more compelling pieces of evidence that the earliest phase of Stonehenge was tracking the moon, not just the sun the monument is famous for. This idea gained fresh momentum in 2024 and 2025 during a genuinely rare event called a major lunar standstill, when the moon's rising and setting points reach their most extreme positions on the horizon, Samet. That happens only once every 18.6 years. English Heritage, working with astronomers from Oxford, Leicester, and Bournemouth universities alongside the Royal Astronomical Society, used the event to test whether Stonehenge's 4 station stones, an often overlooked rectangle of stones set within the monument, were posing, timed to frame the moon's most extreme risings and settings. The long axis of that rectangle points in the same direction as the moon's southernmost rise during a major standstill, an alignment that has been debated for years, precisely because it is hard to prove happened by design rather than by chance. The Aubrey Holes hold one more layer to this story, and it is the one that makes the lunar theory harder to dismiss as coincidence. The cremated remains buried within and around them are not evenly distributed across all 56 pits. They cluster heavily in the southeastern part of the circle, and that cluster lines up with the same southerly moonrise position marked by the station stones centuries later. 3 timber posts were also driven into the earthwork bank at that exact point in the landscape. Whatever significance the builders' attacks heed to that direction, they return to it again and again across different phases of construction, suggesting a deliberate, remembered relationship between death, burial, and the moon's most extreme swing, not a one-off guess by a single generation. None of this required an AI to hand researchers a finished answer. What it required, and what modern computational analysis increasingly provides, is the ability to hold enormous, fragmented datasets in view at once. Excavation records going back to the 1920s, geophysical surveys, radiocarbon sequences, and precise horizons on calculations for lunar and solar positions thousands of years in the past. Statistical modeling lets researchers test whether an alignment like this could plausibly be the product of random pit placement. And in this case, the numbers make coincidence a hard case to argue. The stones themselves tell an even bigger story, and this is where the last 2 years of research have genuinely rewritten the textbook. Stonehenge is built from 2 very different kinds of rock. The massive uprights that dominate every photograph are called sarsens, a type of hard silcrete sandstone. For most of the monument's modern study, their origin was assumed to be local, somewhere on Salisbury Plain. In 2020, a team led by geomorphologist David Nash used portable X-ray fluorescence and geochemical fingerprinting on core samples taken from the stones to track The majority of the Sarsens to West Woods, a forested area in Wiltshire roughly 25 kilometers north of Stonehenge. That is a demanding but achievable haul for Neolithic engineers using sledges, rollers, and rope, and it settled a question that had lingered since the site was first surveyed. The smaller stones, the so-called bluestones, are a different matter entirely. Geologists have known since the 1920s that most of them originated in the Preseli Hills of West Wales, roughly 230 kilometers from Stonehenge in a straight line and considerably farther. By any route people could actually have walked or sailed. What changed in the past decade is precision. Teams led by geologists Richard Bevans and Rob Ixer used rare earth element geochemistry and statistical techniques, including principal component analysis, to match individual bluestone fragments and debris at Stonehenge to specific outcrops in the P. Reselly range, most notably Craig Rosie Phelan and Carn Godog. Excavations at those two sites, led by archaeologist Mike Parker Pearson, then uncovered direct evidence of Neolithic quarrying. Stone wedges, extraction points, and even a rough loading platform, all dated to roughly the same period as Stonehenge's earliest construction phase around 3000 BCE. This settled a genuine scientific dispute. A rival hypothesis, championed for years by geologist Brian John, held that the bluestones were not quarried and transported by people at all, but dragged to Salisbury Plain naturally by glaciers during the last ice age, with people simply gathering up convenient boulders that were already there. The pre-Iowa precision matching of specific stone fragments to specific rock faces, cross-checked against the excavated quarry evidence, has left the human transport explanation on much firmer ground. Though the debate over exactly how the stones made the 230-kilometer journey, whether hauled overland the entire way or moved partly by sea and river, remains genuinely open. Then, in August of 2024, came the finding that actually deserves the word extraordinary. At the center of Stonehenge lies the altar stone, a 6-ton slab of sandstone that had been assumed for over a century to share the same West Wales origin as the bluestones around it. A team led by geochronologist Anthony Clark of Curtin University in Australia analyzed the age and chemical composition of tiny mineral grains, zircon, apatite, and rutile, preserved inside fragments of the altar stone recovered from old excavations, some dating back to the 1840s. The isotopic signatures did not match Wales at all. They matched a geological formation called the Orcadian Basin in the far northeast of Scotland, an area that includes Orkney, over 750 kilometers from Stonehenge. Published in the journal Nature, the study effectively ruled out every other candidate region in Britain and Ireland. Archaeologist Susan Graney of the University of Exeter, who was not involved in the research, called it a genuine surprise. And it is hard to overstate how strange that distance is for the technology available 5,000 years ago. It remains unclear whether the stone was moved overland, by sea, or some combination of both, and researchers openly admit they do not yet know the route. What the discovery does confirm is that every major stone type at Stonehenge, the local Sarsens, the Welsh bluestones, and now the Scottish altar stone, was deliberately sourced from a different, distant part of Britain and brought together in one place. A follow-up analysis published by researchers at University College London and Aberystwyth University in December 2024 argued that this pattern of extreme long-distance stone gathering supports the idea that Stonehenge was never a purely local monument at all, but a kind of unifying project, a physical anchor point drawing together separate farming communities from across the length of Britain at a time when those groups may have had few other reasons to cooperate. It's worth pausing on the alignment most people already associate with Stonehenge because it is the one piece of the puzzle that has never really been in dispute. The main axis of the Sarsen Circle and the horseshoe of trilithons at its centers oriented toward the midsummer sunrise in one direction and the midwinter sunset in the other. Every June, crowds gather outside the stones to watch the sun rise roughly in line with the outlying heelstone. And every December, a smaller but arguably more historically significant crowd gathers to watch the sun set through the monument's tallest trilithon. Excavation evidence from Durrington walls, including the animal bone data described above, points to winter, not summer, as the more likely time for the monument's major communal gatherings, since the pigs were mostly slaughtered at an age consistent with a midwinter cull. That detail matters, because it suggests the solstice event people now flock to see at dawn in June may not have been the primary ritual occasion at all. The midwinter sunset, watched from inside the horseshoe rather than outside the ring, could plausibly have been the more significant of the two. This is a case where new isotope and dentalware evidence has quietly revised a decades-old assumption about which solstice actually mattered most to the people who built the place. The sound of the place turns out to be just as deliberately engineered as its geography, though the real research here is more restrained than some retellings suggest. In 2020, acoustic engineer Trevor Cox at the University of Salford, working with archaeologist Susan Graney and colleague Bruno Fazenda, built a 1/12 scale physical replica of Stonehenge as it would have looked around 2200 BCE when it had its fullest complement of standing stones. Because the actual monument today is missing roughly half its original stones, no full-scale test was possible. So the team constructed a 2.5-meter model inside an acoustic chamber using ley. SIR scanned data from historic England to reproduce the geometry and surface texture of each stone as precisely as they could. What the model revealed was that a complete Stonehenge functioned as a controlled acoustic space. Speech and mew, sick inside the circle, were measurably amplified by more than 4 decibels according to their published results in the Journal of Archaeological Science, without producing the kind of harsh echo you might expect from a ring of hard stone. Sound generated inside the circle stayed largely contained within it, people standing just outside the Sarsen Ring, and certainly anyone further out on Salisbury Plain, W, would have heard very little of what was happening within. Cox has been careful to note that this was almost certainly not the primary reason the monument was built the way it was. Solar and lunar. Alignment likely mattered more to its designers, but the acoustic containment appears to be a genuine, measurable byproduct of the stone's spacing and height, whether intentional or not. And it does suggest that whatever ceremonies took place at the center of Stonehenge were, by design or accident, kept private from the surrounding landscape. Musicologist Rupert Till of the University of Huddersfield, who has separately studied the site's acoustics for years, has pointed out that unresolved mysteries remain, including a low hum. The stones are reported to produce in strong wind, a phenomenon that has not yet been fully explained. The people buried at Stonehenge turned out to carry the same long-distance story as the stones around them. Cremation destroys most of what conventional archaeology relies on to trace where someone lived. But in 2018, a team led by archaeologist Christoph Snook, then at the University of Oxford, applied a newly developed technique for extracting strontium isotope signatures from cremated bone, rather than in tacked tooth enamel. Strontium isotopes vary by local geology and get absorbed into a person's skeleton through food and water over the years before death, effectively recording where someone spent much of their life. Snook's team tested D25 cremated individuals recovered from in and around the Aubrey holes and found that at least 10 of them had not spent their final years anywhere near Salisbury Plain. Their isotopic signatures matched Western Britain, most plausibly West Wales, the same region the bluestones came from. The other 15 individuals tested showed signatures consistent with the local chalk landscape around Stonehenge itself. Published in scientific reports, the study did not claim these individuals are literally escorting the stones on their journey. And Snook himself was careful in how he framed the conclusion, saying only that the isotope evidence was consistent with people, not just materials, moving between the two regions. But the implication is hard to avoid. Whatever motivated the extraordinary effort of hauling multi-ton stones across a quarter of Britain, it involved networks of people, not just quarried rock, traveling the same distances and, in some cases, ending their lives at the very place their stones eventually stood. The quarrying itself deserves a closer look, because it undercuts the old image of Neolithic people as crude, undirected laborers. At Craig Rossi Fellin and Carn Godog, excavators found precise evidence of how the extraction actually worked. The Preseli outcrops naturally split into long columnar blocks along existes. Now, fractures in the rock, and the quarry workers appear to have understood this well enough to exploit it deliberately. They drove wooden and stone wedges into these natural joints to pry blocks free without shattering them, built stone and earth platforms to control how the freed pillars fell and left behind hammerstones used. To work the rock's edges, all without a single piece of metal tooling, since Britain was still centuries away from bronze working when this quarrying took place. This was not improvisation, it was a repeatable technique, applied consistently at more than one quarry site, by people who had clearly worked out the mechanics of the stone they were extracting. The animals eaten at Stonehenge's associated sites tell a strikingly similar story to the isotope evidence from the human remains. Durrington Walls, a large settlement roughly 3 kilometers from Stonehenge that is believed to have housed the workforce building the monument's later phases, produced an enormous assemblage of butchered pig and cattle bone, mostly linked to winter feasting events. For years, researchers assumed the pigs eaten there had simply been raised nearby. A 2019 isotope study led by archaeologist Richard Magwick of Cardiff University, examining strontium, oxygen, and sulfur signatures from more than 100 pig teeth across Durrington Walls and 3 related Neolithic sites, overturned that assumption. Only around 15% of the Durrington Walls pigs showed signatures consistent with a local upbringing. The rest had been raised elsewhere and driven to the site, some from as far as West Wales, some from upland northern England, and some from as far away as northeast Scotland, essentially the same regions later linked to Stonehenge's stones and to the cremated human remains found within it. Magwick's team described this as evidence of the earliest known pan-British gatherings, moments when disparate farming communities from across the island converged on one landscape at real cost and effort, centuries before anything resembling a unified political Britain existed. Cattle isotope work by researcher Sarah Viner had already hinted at non-lock owl animals at Durrington Walls back in 2010. The pig study confirmed it was not an isolated case, but a consistent, deliberate pattern of long-distance provisioning built around communal feasting, most of it timed to winter. Step back from the monument itself and the picture widens even further. Between roughly 2010 and 2020, a research consortium led by archaeologist Vincent Gaffney of the University of Bradford ran what became known as the Stonehenge Hidden Landscapes Project, using ground-penetrating radar, magnetometry, and other remote sensing tools to map several square miles of terrain around the monument without digging a single exploratory trench. The results reframed Stonehenge as one component of a much larger ceremonial landscape, rather than an isolated ring of stones on an empty plain. The survey mapped dozens of previously unknown features, buried pits, ditches, and the remains of timber monuments, some large enough to rival the Sarsen Circle itself. One of the most striking finds was a row of enormous pits discovered near the Henge monument of Durrington Walls, roughly 3 kilometers from Stonehenge, which some researchers argued formed a massive circle over 2 kilometers across, potentially marking a boundary around a sacred zone. That specific interpretation has faced pushback from other archaeologists who question whether all the pits are truly part of one deliberate circle rather than a looser scatter of natural or unrelated features. And the debate over its exact meaning is ongoing. What is not in dispute is that Stonehenge sits within a landscape that was works modified and monumentalized by Neolithic communities on a scale far larger than the stone circle alone suggests, including the massive settlement at Durrington Walls itself, believed to have housed the workers who built the later phases of Stonehenge, and timber circles, whose post holes suggest structures that once rivaled the stone monument in scale, if not in permanence. Piecing together dating evidence from across all these excavations gives Stonehenge a construction history that unfolded over an extraordinary span of time, roughly 1,500 years, not as a single build, but as a sequence of distinct projects layered on top of each other. The Liast phase, the circular ditch, bank, and Aubrey holes dates to around 3000 BCE. The bluestones appear to have arrived and been rearranged multiple times over the following centuries. The iconic Sarsen Circle and trilithons, the part most people picture when they hear the name Stonehenge, were raised around 2500 BCE using stones hauled from West Woods. The altar stone's exact arrival date is still uncertain, though researchers estimate it was likely set in place during that same general period, sometime between roughly 2620 and 2480 BCE. Even after the Sarsens went up, the site continued to be modified for centuries, with stones rearranged, some removed, and construction activity generally tapering off by around 1600 BCE. Archaeologist Mick E. Parker Pearson, whose excavation team documented the site's later phases in detail between 2008 and 2014, has described this closing period not as sudden abandonment, but as a gradual winding down of activity, consistent with a monument that had served its central ceremonial purpose and was slowly being left to the landscape rather than dismantled or destroyed. So where does artificial intelligence actually fit into all of this? Honestly, rather than dramatically. It is not the case that researchers fed a single archive into a chatbot and received a revelation. What has genuinely changed is the scale and sophistication of the computational tools available to interpret the kind of data Stonehenge has been generating for a century. Statistical pattern matching techniques let geologists compare the chemical fingerprint of a single bluestone fragment against thousands of possible source rocks across Britain and Ireland and return a confident match. Digital terrain modeling and geophysical survey processing let archaeologists convert magnetometer readings from square miles of farmland into a coherent map of buried features invisible to the naked eye. Computer-based acoustic modeling let engineers simulate how a 5,000-year-old structure that no longer physically exists in its complete form would have sounded without needing to guess. Radiocarbon calibration software processes decades of dating results from different labs into a single statistically coherent timeline. None of these are science fiction. They are the ore de geological science, and their cumulative effect over the past 6 or 7 years has been to overturn assumptions that had stood, in some cases, for a century. The Alterstone's Welsh origin W as textbook fact until 2024. The idea that the Sarsens were sourced locally was accepted wisdom until 2020. The notion that cremated remains could even yield reliable isotope data was considered technically impossible until Snook's team found a way around it in 2018. What emerges from all of this is not a monument built by some unexplained lost civilization with knowledge beyond its era, But something arguably more impressive, a 5,000-year-old testament to just how far Neolithic Britain's ambition, cooperation, and engineering skill actually reached. People without metal tools, wheeled vehicles, or writing organized the extraction and transport of stones from 3 regions of Britain separated by hundreds of kilometers, timed at least part of their monument to track a lunar cycle that would not be formally described in Western astronomy for thousands of years afterward, and shaped an acoustic space precise enough that modern engineers can still measure its effects in a laboratory. However, they did this not with one flash of genius, but across 5 centuries of construction, involving generations of builders who never met the people who started the project and who kept adapting it long after its original purpose may have shifted or been partly forgotten. The mystery of Stonehenge was never really about needing an advanced or otherworldly explanation, and it was about the limits of what any single excavation, survey, or research team could piece together on its own. What has changed is not the monument, it's our capacity to finally look at all the evidence at once. And even now, with every one of these breakthroughs, the central question, what it actually felt like to stand inside that ring of stone under a solstice sky or a standstill moon 5,000 years ago, remains exactly as open as it always was. If this deep dive into what modern science has actually uncovered about Stonehenge gave you a new way of looking at it, subscribe for more evidence-based investigations into history's biggest mysteries. Leave a like and drop a comment with the finding that surprised you most. There's a lot more buried in the data than most people realize, and we're just getting started.